All right, guys. So I want to create a cliff notes on tonicity. So what is the tonicity? Tonicity is the amount of solute in the solution, right? So let's look at this structure. Amount of solute in the solution. So let's pick a color, and we're gonna create a solute. So solute could be molecules like sodium, for example. So top portion is a hypotonic solution, and the bottom portion is the hypertonic solution. So this is view from, that's a view from on this side, on the right side. This is view from the top, and this is view from the side. So I will mimic on both sides, so it is easier to understand. So tonicity, amount of solute in the solution. So this is a cell, represents, this circle represents cell. So I'm going to use another color. So let's say this is cell, and also this is cell, right? But only a side view, right? So this is side view, this is top view. So let's put solutes. So let's say on a hypotonic solution, we have a few sodium molecules because in this particular example, our solute is a sodium. But inside of the cell, right, also we put here, hypertonic solution, a few solutes outside the cell. However, inside of the cell, we have a lot more of those solutes. Again, sodium molecules. Right? So top view and side view. I don't know, why am I doing top view and side view? It is easier for people to remember either top view or the side view. We all have different ways of learning and remembering things. So also in both compartments, which is outside the cell, which is here, and inside of the cell, which is there, we have a liquid, we have water. So let's say H2O we have here, and H2O also we have here. And there always should be an equilibrium, there should be a balance. So, and the solutes, they're responsible for equilibrium, for water balance. Let's say in this case could be sodium, potassium, right? So now I want to look at the movement of the water through law of osmosis. So if there is a more solute inside of the cell, through the law of osmosis, water will follow particles. Water will go where there is the highest concentration gradient of certain particles. So just because the water is outside, but there is more particles right here, water will enter a cell. Water will enter a cell in a hypotonic solution because there's more particles inside of the cell, and water will enter through the law of osmosis. So when the solution is hypotonic, cell will get a lot of water and will start growing, inflate, and can burst. That can lead to cell death. This is a hypotonic solution, amount of solutes in a solution, and that's the solution outside. In hypertonic, it is the opposite. So let me, I guess, pick this color, right? Or guys, I'm colorblind. For me, it's hard to pick a color. So in hypertonic solution, there's a lot of particles that are in solution, and there's less particles inside of the cell. On the top view, that's the same thing. So in the hypertonic solution, there's more particles, and inside of the cell, there are less. So guess where water is gonna go right now? In this case, just because there are more solutes outside the cell, the water will escape the cell and will go towards highest concentration gradient of the solute. Again, law of osmosis, because there's a membrane, semi-permeable membrane. So in this case, when water leaves the cell, cell will be crushed, it will crescent, it will shrink. And that can lead to a cell death as well. So if you look at these images, This is a isotonic solution, meaning it's equilibrium. It's the equal amount of solute inside of the cell and outside of the cell. So the water can move freely, and so there's equilibrium and balance on both sides. In this case, it is a hypotonic solution. So the water, the arrows indicates the movement of water. Water enters where there's highest concentration gradient of solutes, and the cell will grow and burst and die. In this case, it's the opposite, hypertonic solution. There's a lot of solutes outside of the cell, and there's less of solute inside of the cell. So the arrows indicates that the water will leave the cell, and the cell will be crushed, crescent, or crenation. There's a lot of vocabulary to that particular state. So the tonicity is the amount of solute in the solution, not in the cell, but in the solution. And that's why we can distinguish between hyper or hypotonic. So I hope that was an easy explanation. Cliff notes on tonicity of the cell.